Hi, welcome back everyone. This is me, of course. It is Rooney Lin, and today is Sunday, first Sunday of April, to be honest, 5th of April on Sunday. Today, I'm going to record another educational recording video once again here on brilliant.org. As I'm recording this will probably mark my 30th exercise so far, explaining this chapter in more interesting concepts. 30th exercise, but I mean excluding other like surprise videos or recap warm-up videos not involving these, but kind of particular exercise, very new one that I'm going to talk to you right now. So today I'm going to choose this advanced math. Objective is to dive into key ideas in derivatives, integrals, vectors, and beyond. Something I haven't discovered or present to you like for a very long time, since like that one was about 4 months ago, I think, like last December. So returning with this calculus with a pointer here, right? Everyone see that? So I'll click on it. That's right. Finally, this is calculus, to investigate the central ideas of calculus and learn how to put them to use. Sorry, like I haven't record these videos, although I've done some exercise like for such a long time, like I have to return kind of describing some mathematical calculus chapters and exercise, what key features might be mentioned in this recording. So here's level 3, finding derivatives. Currently I'm at apply, what's the term called, optimization. That's chapter what I'm going to do today, like going to start this presentation and demonstration to all of you, right? So I'll click the start button to begin the lesson now. There we are. I think I've just entered. Wait. That's right. This is called brewing the best shot. Wow. Let's use our knowledge of how to find derivatives to find the optimal time for coffee extraction. That's right, kind of particular experiment with its derivatives, how they are applied to the calculus mathematical terms, right? So I'll click continue. That's right, here is what has been given. Experimental data for a home coffee brew gives us the following function. E to the variable of t equals this one. I'm not going to read it out because it takes a little too long and become more complicated. Right, here e to the variable t is the extraction yield at time t. So t is the x-axis and e is the y-axis. So like here's first derivative equals 0.7 means particular gradient of that function along the point of x values. So if I drag it like this, like 6, 5, 4, gradient is decreasing, and this is gradient is 0 stationary, when first derivative equals 0, like kind of stationary curve point, I think. And then greater than that would be much negative gradient along this point. Right, I'm not going to tell you that anyway. You just discover first derivative, how this gradient change over time, like time t variable. I'm not explaining that. Continue. That's right. Here's another feature that has been provided. It's recommended to stop brewing at the peak extraction time for the best flavored coffee. First, we need to find that d over dt of this function, that's, first derivative. However, which rule makes sense to apply first to find e to the delta, that first derivative? Which rule? Let's see. It can't be sum. It can't be product. Because this is divisible function, so it should be quotient rule, right? Let's check it. Of course, this is correct. Why? That's right. Function e is a ratio of two polynomials, so it makes sense to use quotient rule. Only that would be applied. All the others, like sum, product, or chain rule, will not probably work here. But I'm not going to explain why that they do not. Continue. Here's kind of additional statement that has been given to all of you, so I'm going to read it out loud. To apply the quotient rule, we need to find the derivatives of the numerator and denominator. Let's say that e to the variable of t equals this, like for example, f to the variable of t divided by g to the derivative of t. Let's assume like this. But what is the derivative of f to the variable t equals 10t? That's simple. T is cancelled out, so it must be 10. Simple problem, I think. Let's check. Of course, it is correct. Why? That's right. Explanation here gives that the function f to the variable of t equals 10t is linear with a slope of 10, so its first derivative must be equal to 10. Alternatively, the power rule can also be applied to get the same answer. Right? I'll close. Kind of simple problem that you already know how to calculate this, right? Continue. Here's another problem for sure. What is the derivative of g to the variable of t of this? I think like kind of use the product rule. For example, like 0.1 t to the power of 2, I think times 2 power reduced to 1, so 0.2 t is 0.5. Right? Only this one should be the correct answer here. Let's check. Of course, it is correct again, but why? That's right. Explanation here gives that the derivative of g to the variable of t for this formula, yes, equation, alternatively, can be found with the sum, constant, multiple, and power rules. So you have to apply this. And it becomes 0.1 times 2t plus 0.5 times 1. This is t to the power 0, so cancel out. So rewritten as 0.2 times t plus 0.5, right? Kind of product rule you have to apply for it. Anyway, I'll click continue. Yes, here it is again. Now that we have e to the variable of t equals this and the following here, I'm not going to re-explain it. Now we can find overall e to the first derivative of t, or use the quotient rule that we already discovered here, but not recording this video yet. Great, let's scroll it down. Just 3 of them. G to the t, yes, so not this one, either first or second. G to the t. Wait, g to the t times 10 minus. This is minus. Actually, this is plus. So plus is not correct. I think this one. It must be the only correct answer here. Let's check it. Of course, this is theoretically correct as I've just discovered. Why? Yes, the explanation here gives that we can plug in all these variables given to the quotient rule. So finally, the result here is obtained. I'm not going to read it out because like taking such a long time, very complicated to read. So you just scan it and give a pause to write that equation if you wish to. I'll close. Just move forward and click continue. Yes, here's also what's been given. We can simplify the derivative this to this. Oh, let me give me like 10 seconds to read how they simplified it. 10 minus t squared and then this square. Oh wait, e to the first derivative equals 0. Don't apply this denominator. Numerator must equal 0, so t is, yes, like t squared is 10, so square root of 10, not 5 or 10. Only this one must be correct. correctly applied. Let's check. Of course, this is correct as expected, but why? Of course, here it is. The explanation gives that for this e to the first derivative of t, this numerator above the denominator, only this. Of course, like if the numerator is 0 and the denominator is not, function is 0. Of course, if 10 minus take away t squared equals 0, then that numerator must be 0. Happens when t equals square root of 10, approximately 3.16. Right? Kind of simple problem. Probably you just discovered, isn't it? Anyway, continue. That's right. Last but not least, here's the final statement that has been summarized from this experimental chapter lesson that we've learned. I'm going to read out loud, so you all better listen this. So, the optimal brew time using this method is about approximately 3.16 minutes. Too long and the coffee might be bitter, and too short, it might be weak. Of course, brew time should not be too long or too short, probably at its optimum value. Kind of optimization data that you've just evaluated using graphical calculations and the derivatives using these data with product rule, quotient rule, and many more. You just discover everything, right? Anyway, that's the end of today's lesson, and I'm going to click on this finish tab to conclude this session for today. Wait a second. Yes, lesson complete. As a result of this completion, you see I've gained 85 XP experience points this time around. Just look at this, right? What this is watching. I think like kind of another level completion. So wait, you wait a second. That's right. Just complete every single chapter from lesson level 3. So probably stepping up onto level 4. That's what I'm going to explain you in just in a moment. Continue. Boom. You see what? That's my another remarkable achievement of achieving 30 consecutive days, 30-day streak here on Brilliant.org with that perfect lightning bolt. That's once again amazing, isn't it? Smartest month ever. 30-day streak, like also getting lucky to achieve this because like I was kind of getting salvation, saving that streak, like kind of some heroes coming into this online Brilliant.org by surprise. But I'm not going to tell you that again, so continue. Alright, there we are again. Calculus, level 3, every single exercise is complete. If I screw up, optimization, experimental chapter that I've just presented is complete. So I've just stepped onto a new level, like I've just described to you, like level 4 is integrals. What's the first exercise? The area problem. But I'm not going to record this video like kind of because mathematical calculus sometimes it might not be too tricky, but very theoretical to explain every single concept or feature inside it. Anyway, that's it for my educational video recording today. Thanks very much for watching. If you enjoyed this, don't forget to add a like and subscribe. Like you click on the subscription tab whenever you review my channel. Kind of similar educational recording videos that I've previously recorded for several times previously. Like I do this recording every single week. Also keep on track recording more like this in the future. So with your subscription that you might wish to provide, kind of preview more of my videos that might be coming up in the future with further announcement to be made, right? Anyway, that's the end for today. So I'm leaving this session for now. Take care, guys. Cheers. Have a great day and bye for now.